Okay, good. Okay, so good evening, everyone. Good evening. So myself, Samanvit, I'm your physics faculty over here. So welcome to today's session. So before going ahead, I'm launching the technical poll, and also I want reply from the chat too. Yeah. Good evening, everyone. Yes. So let me know, is my screen is visible or not? Is my presentation visible or not? And is my audio is clear or not? Is it perfectly clear? So that there is no yes, thank you, sweetie. So I'm launching the technical check, so please let me know, okay, because we don't want any issue moving ahead. So whoever has joined now, hello Parth, good evening everyone. Students from Ballari, good evening. Students from North Canada, good evening. Sweetie, good evening. The JNV Dharwad students, good evening. Okay, so most of you have answered, so and I can see there is no technical issues. Okay, then that is the case, then we are going to proceed ahead. And also, students who have joined in YouTube Live, welcome to today's session. Okay, so what we were studying in the last class, students, we were talking about Newton's laws of motion. Okay, so we are going to continue regarding Newton's laws of motion, and already you have studied one of those laws. Yes, that is first law. First law is already done by whom? It was done by Sham. So I hope you have studied those things and all. As I said in the last class, we are not going to directly jump into second law of motion unless and until we are going to we are going to study certain terminologies. So these terminologies are very, very important to understand the numericals based on first law and numericals based on what second law. So whatever we are going to study, like from yesterday, let's say yesterday we studied and today also, it is very important for your numericals. Okay. So before going for today's session, let us quickly go to the contents of today's session. See, first, what we are going to do, we are going to quickly recall what we have studied in the last class. Okay, what we have studied in the just a second, give me a second. Yeah. So we are going to quickly recall what we were studying in the last class. Then we are going to talk about students. Today we are going to talk about tension. ये वो वाला टेंशन नहीं है अथवा ये other tension अल्ला yeah where you take like oh exam is going on those tension. It's not that tension. Okay, let's say you have a mass and there is a string and you are trying to pull this string. Okay, and there is a tension that is created. Okay, that tension is created, so we are going to talk about that tension. Okay, students, then later on we are going to talk about tension in a pulley. Tension in a pulley. Okay, so I know there are, see, we are not going to talk about the problem of pulley. We're not going to talk about the problem of pulley, but we are going to analyze, basically analyze, yeah, how tension acts in a pulley, basically. Okay, then there are certain points regarding tension. We are going to study about that also. Then we are going to talk about free body diagram. This is very, very important for solving problems, students. And solving problems, this is very, very important. Okay, then what? Then we are going to talk. Then that's all. Then we are going to talk about the summary of today's class. So is it good, students? And since there is network issues, so let me know constantly that am I audible or not? Okay. So it would be really helpful. And let the ads be with let's say doubt or whatever you want to ask. Okay, students, is it good? Chat. Yes, students, please let me know. Okay, yes. Okay, just okay. Good. Is it clear now? Let me know. Krishna, let me know. Abhay, let me know. There's certain issues. Wait, I fix it. Give me some 2 minutes. Wait. It's off due to the power cut over here. ठीक है? जब power आ जाए on कर दूँगा. Is it good? Okay. Okay, then talking about what we studied in last class. What we have studied in the last class. Okay, quick recall. Do you remember what we have studied in the last class? Do you all remember? What did we study? We talked about what concept of force basically. Yes or no? Yes, students, where we told that force is the external form of push and pull. What? Force is the external form of push and pull. Yes, I hope every technical issues is cleared now. So we said that if a person, let's say, if you're applying a force, that is what? Push. Okay, you're pushing a box or pulling it, then it is called what? Force. Yes or no, students? But as I said in the last class, the concept of force is not complete unless and until you talk about point of application. Yes. And also I said that force is a vector quantity. Why? I told that force, see, force, what is a vector quantity? It has both direction as well as what? Magnitude. Magnitude. Yes or no? See, the direction along which you are applying the force will decide the what? Decide the path of it. Yes or no? Yesterday we saw that whenever there is a like basketball, a basketball playing is going on, and the person will try to hit that ball and change the direction of the force. Yes or no? Similarly, we saw what mass of block M. Okay, mass M, and I told you I want to move the block with the velocity v. Where should I apply the force? Okay, Abhay, thank you. Where should I apply the force? The force should be applied over here. Yes or no? I can't apply the force over here. Let's say F2, F1, F2, and say that it will move with the velocity v. Yes. So the what the direction of application of force is very, very important. Also the point of application. Yes or no? Yesterday also I showed the what. So the let's say if there is a bottle, if this is the point of application, let's say yes, if this is the point of application, just a second. If this is the point of application, if I push this, it is going to move. But if I applying the point of application over here, what will happen? My bottle will fall. So point of application of force is very, very much important, students. So I hope you remember all these things. Okay, all these things. Then students, what did we talk about? We talked about what this force can do. What this force can do. Yes or no? What this force can do? The force produce or tries to produce motion in a body as rest. Yes or no? We saw that, let's say if you have a football and you're trying to kick it, basically what you're doing, you are applying a force. You're applying a force. This object, this football is at rest. So it tries to produce, yes, producer tries to produce a motion in a object which is at rest. Then what stops or tries to stop a moving body. Yes or no? When we saw that the superhero, who was it? The Superman was trying to what? Stop the car. Stop the car with his superpower. I hope you remember this also. I hope you pictorially remember that, because see, I believe if you see pictures, it is much more relevant to you and you remember all of these things. Okay. See, I'm going little faster because it's a recall of yesterday's class. Okay. So let me know with the thumbs up. Is it good? Is my pace is good or not? Every JNV students also, if you are able to reply with the thumbs up or anything, that would be very nice. Okay. Okay, Bala. Okay, good, nice. Part good. Manthan, very nice. Others. Anyone else? Okay, good. Kodagu, okay. So everyone has joined now. Very, very welcome to today's session. Okay. Then what happened is we talked about what changes the force, changes or tries to change the direction of motion of a body. I also said the same thing, right? See, if there is a moving body, okay, this is the pen. Okay. If I'm applying, if it is falling down and I'm applying a force, then it will jump over here. Yes or no? If I'm applying a force from here, then it will change the direction. So applying a force will also change the direction of the what motion of a body, and also what produces a shape in what change in the shape of the body. Yes or no? We saw that there was this Hulk. Yes or no? You know, everyone knows about Hulk. So if he smashes, if he says smash, Hulk smash, then what? He smashes everything, right? So if there is a box, then if he smashes it, then it becomes what? Basically pieces of boxes. So here the shape of the body has changed due to the what? Due to the application of force. Students, is it good? Nice. Then later on, we talked about what? Classification of forces, students. Abhay, very good. We talked about classification of forces. We told that there is what? Non-contact forces, contact forces, weak forces, and what? Nuclear forces. As I said, this force, about this, you are going to talk about in your 12th, so don't worry about it. Yes. Then this force is going to cover in what? Chemistry. Basically, this is van der Waals force, okay? Van der Waals force. These forces will be studied in your chemistry, okay, in detail. So don't worry about it. And I was talking about contact forces, yes or no? Where, see, a contact is required, a contact is required. Then only there is a force is generated, yes or no? Let's say today we are going to talk about that tension force. Then we also said that there is spring force, yes. Then we also talked about what? Non-contact forces, yes or no? इसमें कांटेक्ट की जरूरत नहीं है, जैसे कौन सी? ग्रेविटेशनल फोर्स है कि नहीं? ऐसा नो स्टूडेंट्स, हाउ द? हाँ, जैसे अर्थ, जैसे सन एंड द अर्थ, कुछ कांटेक्ट है क्या? रिवॉल्व कर रहा है, किसकी वजह से? ग्रेविटी ना, ग्रेविटेशनल ना. ऐसा नो स्टूडेंट्स, लेट मी नो. Yes, and also you know that the formula for it is g m1 m2 by r square. देखो, इसके बारे में अगर पढ़ा नहीं है, and if you are not gone through this, don't worry, there is a dedicated chapter for it, okay? Ready? Parth, can you explain contact and non-contact forces? ठीक है, okay. देखो, पहली बात तो what is contact? Contact का मतलब क्या होगा पार्थ? Let me know. अगर मैंने यहाँ बॉटल रखा है, ठीक है, बॉटल रखा है और मैंने इसको पकड़ा, तो ये कांटेक्ट हो गया, नॉन कांटेक्ट होगा? ये बताओ, व्हाट इज दिस? कांटेक्ट होगा ना, है कि नहीं? अभी ठीक है, हाँ, अभी मान लो मेरे पास ये वाला एक थ्रेड है, ठीक है, ये थ्रेड है मेरे पास. अगर मैं ये कांटेक्ट पे है ना, अगर एक कुछ मैं इसको पुल करूंगा तभी एक टेंशन या फिर एक फोर्स लगाएगा ना. यस और नो स्टूडेंट्स? यस, पार्थ, there is a force because of the contact of what? Let's say contact of my hand with this string. So over here there is contact of something, मतलब एक टच होनी चाहिए जिसकी वजह से एक फोर्स जनरेट होगा. जैसे मान लो ये, अगर मान लो स्प्रिंग है तो ये वाला है ना, जैसे मान लो एक ये वेट है, ये की चेन है ना, तो अगर मान लो इसको मैं खींच रहा हूँ, एक टेंशन वगैरह आएगा, टेंशन में एक फोर्स आएगा जिसकी वजह से थोड़ा ऐसे पुल हो रहा है, ठीक है. So that is what, there is a contact between the objects. अभी मान लो नॉन कॉन्टैक्ट फोर्सेस, फॉर एग्जांपल, ठीक है, मेरे पास जादुई शक्ति है, ठीक है, देन इफ आई एम ट्राइंग टू व्हाट पुश दिस, ऐसा पुश होगा, ठीक है, ऐसा पुश होगा, देख रहे हो, ये क्या है? नॉन कॉन्टैक्ट फोर्स होगा ना. आई हैव स्पेशल पावर्स, ओके. फॉर दैट रीजन स्टूडेंट्स, दैट इज द डिफरेंस बिटवीन कॉन्टैक्ट एंड नॉन कॉन्टैक्ट फोर्सेस. इज इट गुड? हाँ, पार्थ, लेट मी नो इन द चैट एंड अदर्स लेट मी नो. देखो, जैसे मान ग्रेविटेशन बोला था, ऐसा नो, एंड आल्सो देयर इज दिस इलेक्ट्रोस्टैटिक फोर्स, इलेक्ट्रोस्टैटिक फोर्स. हाँ, वेरी गुड. सो इलेक्ट्रोस्टैटिक फोर्स बेसिकली क्या है? चार्जेस के बीच में होता है ना, ऐसा नो, लाइक चार्जेस रिपेल, अनलाइक चार्जेस अट्रैक्ट. तो चार्जेस के बीच में होता है, उसको कांटेक्ट की जरूरत ही नहीं है. ओके, इज इट गुड? अदर्स लेट मी नो. वेरी नाइस, ओके. Okay, then moving ahead, we talked about what? Gravitational force, yes or no? See, I told that here one of the important thing that has to be noted was, see, for an earth, if you keep the mass m, if you keep masses, okay, sorry, this is the mass and the mass, and I asked you, if this is the center of the earth, where will the weight act? So weight was acting along the center of the earth, okay. Then what? That is mg, and mg, that is the weight. And I told you that we consider this surface, yes, and this surface is called what? Plane surface, okay, plane surface, basically plane surface, and this is the mass. Then only you can say that the weight is acting, mg is acting what? Vertically downwards, okay, vertically downwards. So then only you can say, see, unless you know the concept, students, never say that the weight is acting vertically downwards. Since you're taking the part of the earth, then you're considering it to be a plane surface, then you say it to be vertically what? Downward, students. Okay, is it good? Then what did we talk about? 8 minute ruko. I'll write it very nicely. Vertically downwards. Yes. Then we talked about what? Normal force. Yes or no? What is normal force? When a rigid body is placed in a rigid surface, the body experiences a force which is perpendicular to the surface in contact. देखो मैंने बोला था अगर there is a mass body of mass m, okay, and weight is acting mg. देखो मैंने बोला था कि अगर वेट रखा है, देखो अगर मैं यहाँ खड़ा हूँ तो वेट मेरा नीचे जाएगा. ऐसा नो, लेट्स से दिस अ प्लेन सरफेस वर्टिकली डाउनवर्ड्स होगा, but I'm not going inside the surface. So no, something is avoiding me, like something is making sure that I don't go inside the what? Inside the surface, and I called it to be what? Normal. Over here, students, see, this is the surface, this is the surface, and this is the object. The surface is like providing a normal force on the object. So you write NSO, and I told you that this normal what exists in pair. Okay, exists in pair. I told that there should be a what? Equal and opposite force. Okay, equal and opposite. Opposite. We'll talk about it in the what? Newton's third law of motion. Don't worry about it. So it exists what? Equal and opposite force. Hence, there is another normal force which is acted by the object on the surface. Okay. So these were the things we taught, and also students always remember that this what? This normal force is what? Perpendicular to the surface. It is what? Perpendicular to the surface. Is it good, students? Always remember, see, अगर ये surface है, ये वाला surface है, ये perpendicular होगा ना, ये जो act को होगा ना, वो perpendicular, वो 90 degree पे होगा. Is it good? So perpendicular is 90 degree basically. So ये this is very very important. Okay. Others, let me know in the chat. Is it clear till now? Agar yes, if it's clear, if yesterday's class is clear, then what? Okay. Then also what? We did talk about balanced forces. Okay. I did forget about it. So there was this balanced force we talked about. What was the balanced force? Let's say we represent using what? Tug of war. Okay. Tug of war ho raha hai. Okay. And everyone is trying to pull each other. Yes or no? From one end and another end. If there are two teams, like one team and second team. And if they're applying equal forces, let's say 10 Newton, and force is equal to 10 Newton, but in the opposite direction, then what is happening? This point is not moving. It will not move. Yes or no? It will not move. Then that force is called balanced force. Yes or no? Then again, we talked about what? Unbalanced force. What was this force? Let's say we have force is equal to what? 50 Newton, and this force is what? 10 Newton. What is happening over here? Tug of war हो रहा है. अगर जीतने के लिए ज्यादा फोर्स लगाना पड़ेगा ना, तो one end of the team, let's say one team is applying more force compared to the other team, and it's applying in the opposite direction to each other. Okay, but the force is much more than the other team's force, and that is called unbalanced force. Okay, is it clear, students? Is it clear till now? Let me know. Everyone in the chat, everyone who is in the present in the chat. Very good. Others? Yes. Okay, very good. Okay. Others, students from every JNV, let me know. Okay, if you're in JNV, if you have any doubt, let me know through the chat. If you are able to provide the chat, like through the chat itself. Very good, Ansari. Okay. If not, then don't worry. You can ask separately the doubts. Okay, so that let's say people from over there can text me on WhatsApp. Is it good? Nice. Then if that is the case, students, here is a quick question for you guys. Okay. Now I want to know where will the normal act on this body. There is a body of mass m. Okay. Okay. And there is a what? A surface over here. This is a surface. Now I want to know where will the normal act. Okay. The first thing, everyone has this urge. Okay. अगर एक बॉडी देख लिया ना, हमें पहला चीज एक दिमाग में आता है कि हाँ, एक वेट होगा, वो नीचे एक्ट करेगा, m into g. ठीक है, ये हो गया हमारा सेटअप. अब मुझे ये बताओ कि नॉर्मल कहाँ एक्ट करेगा. लेट मी नो स्टूडेंट्स, वेयर विल द नॉर्मल एक्ट? will act, हाँ, it will act on the surface. Okay, but okay, I'll give a hint now. ये ऐसा एक्ट करेगा, मान लो. okay, I'll write it. अगर मान लो ये बॉडी है अभी, अरे रुको 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 रुको, तो ये एक सरफेस था, ये बॉडी था ना, एंड दिस इज द वेट. ओके, ये जो नॉर्मल है वो ऐसा ही एक्ट करेगा या ऐसा एक्ट करेगा या ऐसा एक्ट करेगा? कैसे एक्ट करेगा? 1, 2 और 3 perpendicular to the object, normal force acting. Sweetie, very good, very nice. See, students, as I said, normal. Ballari, okay, no, wait, okay, JNV Ballari students, okay, see, normal force or normal reaction will always act perpendicular to the surface. अगर मान लो ये वाला सरफेस है, this if this is a surface students, okay, ಮಕ್ಕಳು ಇಲ್ಲಿ ಕೇಳಿ, ಇದು ಸರ್ಫೇಸ್ ಆದ್ರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದಾಯ್ತಾ? ಕರೆಕ್ಟಾ? ಹೌದಾ? ಇದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರಾ? ದಿಸ್ ಇಸ್ 90 ಡಿಗ್ರಿ, ಹೌದಾ? ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಇದು ಸರ್ಫೇಸ್ ಆದ್ರೆ ದಿಸ್ ಇಸ್ ಅ ಸರ್ಫೇಸ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ ಆಬ್ಜೆಕ್ಟ್. ಬಳ್ಳಾರಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಹೌದಲ್ಲ? ಹೀಗೆ ಬರುವಂತದಲ್ಲ? ಹಾ, ಕರೆಕ್ಟ್, ವೆರಿ ಗುಡ್. ಸೊ ಇಫ್ ದಟ್ ಇಸ್ ಅ ಕೇಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ನಾರ್ಮಲ್ ಎಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ಬೇಕು? ಹೇಗೆ ಆಕ್ಟ್ ಆಗ್ಬೇಕು? ಐ ಸೆಡ್ ದಟ್, ಸಿ, ದ ನಾರ್ಮಲ್ ವಿಲ್ ಆಕ್ಟ್ perpendicular to the surface. Basically, you know that, see, agar weight is acting downwards, you know that the surface will act, what it will apply a normal force on the object. If that is the case students, then the normal force will be what? Perpendicular to the surface, and this is what? Normal force applied by the what? Surface on the object. And also I said that there is a what? There is a equal and opposite force for this. Since this what exists in pair, then you get what? And another normal force, which is basically what? Applied by the object on the surface. Okay, NSO andre surface on object. Okay, andre normal force. Krishna, okay, sure. Abhay, I was talking in Kannada too, because they're a Kannada student, so I'll be using Kannada, English and Hindi. Okay, so I'll be repeating the same things, don't worry. I won't use a different sentence with different languages. If I'm saying what is my like my name is Samanvit, I'm going to talk about the same thing in different languages. Okay, so let every student have that opportunity to learn, okay, to understand basically. And also and OS is what? Object on surface. Okay, yes, is it good students? So have you able to do this, or like were you able to do it, and did you understand what is happening over here? Yes, okay, good. Others, let me know. Okay, good, very nice, clearly, yes, very good, Krishna, nice. And who, okay, JNV Ballari students, is it clear now? Since you applied one as the normal force, is it clear now? JNV Ballari students, let me know, because I don't want anyone to get confused. Okay, good, nice, that's very good. Okay, so if that is the case, then we are going to talk about what? Tension now. As I said, ये टेंशन वो वाला टेंशन नहीं है जो आप मान लो कल एग्जाम है तो भगवान के लिए प्रे करते हो ना, भगवान प्लीज हमें क्या बचा लो, है कि नहीं? ऐसा ना स्टूडेंट्स ಮಾಡಿದಿಲ್ಲ ನೀವು? ನಮಗೆ ಇದು ಪಾಸ್ ಮಾಡಿ ಬಿಡು, or ಇದು lucky same question, let the same like similar questions come, or let's say we want to know the important concept, or we want the question paper itself. This is not that tension at all. Okay, this is not that tension. The tension is basically over here is what students? It's about let's say there is an object and there will be a let's say anything. Okay, I won't talk about what is this, let's say a rope or whatever, and when you apply a force over here, there is some tension is created, the certain force is created. We are going to talk about that. Okay students, is it good? Students? Okay, now if I'm talking about the tension, see, this tension comes in picture of what? A string, a rod, or a chain. Okay, so every time if you see some question that is regarding string, rod, or chain, at that moment itself you need to understand that, okay, I need to apply what? Need to apply tension. Is it good students? So whenever there is a string or a rod or a chain is involved, then you need to understand that, okay, so whatever we need to do is we need to apply tension. Okay, students. Now let us go to the diagram that I have drawn. Okay, this one, the figure. Over here, okay, you know that this is a ball of object, okay, of mass m, and it is attached to a surface. This is the surface. It is attached to a surface, yes or no? And now you know that, and it is attached through a, let's say, string. Over here, it is attached to a string. Now, students, let me know. See, as I said, every student has this urge. Whenever they see something of this image, they do a arrow mark. That is what weight, basically. Weight is equal to m into g, which is acting what? Vertically downwards. Abhi tak clear hai? Is it clear till now? Is it clear till now, students? So kya ho raha hai? See, there is an object and it is attached to a string. Let's say this over here. Okay, over here is attached to a string. Yes or no? Now, because of the weight, because of the mass, there is some weight created. Yes or no? Now, over here, can you see that? Let's say it has some weight. Okay, this keychain has some weight. Can you see it? This keychain has some weight. Okay. Now, is this keychain going down? Is it going down because of the weight? Is it going down? No, right? Let's say this surface. Ha. If it is not going down, there should be some force that is like, what do you say? It is not allowing that key, or let's say that mass, to go down. Yes or no? Now that force is called what, students? Tension force. Basically, tension doesn't allow what, the mass to go down. Okay. Now, students, when you're talking about it, see, the tension that acts over here, since the weight is acting over here, the tension will act what? Upwards, in the upwards direction, and we denote it using what? T. So, students, the denotion for, we denote tension using the symbol T, and it acts basically what? Always is acts away from the point of consideration. Okay, students. So what it will act in the, see over here, you can see that. Okay, let's take this mass, and this is acting, this weight is acting m into g, and the tension is acting in the what? Opposite direction of weight. Is it good now? Have you got a slight idea about what is tension now? Don't worry, as the class progresses, we'll talk about more and more about tension. But did you get an idea about it? Okay, others, let me know. Sweetie, Krishna, Meera, Manthan, Ansari. Okay, very nice, very good. Okay, now what? See, when you talk about tension, the definition says that a force exerted by the end of taut string, basically a string or a rope or a chain, against the pulling, or देखो ये pulling था ना, ये वाला pulling था ना अबे, yes or no? हाँ, पढ़ ले students, very good. This is pulling, right? है कि नहीं? So the pulling force is called tension. Okay, the direction of tension is so as to the what? Direction of tension is so as to the pull of the body. Basically, it is in the what? Opposite direction as the direction of weight. Okay. Now, students, okay, Iga, now, how do you consider this force, or how do you consider this what? Tension. Now, let's say, what you need to do is, you have this mass, okay, okay. Now, what will I do is, let's say, okay, which student will act, okay, let's say, Abhay is over here, okay, Abhay is sitting over here, Abhay, okay, you are sitting over here. Okay, now see, now Abhay want to know where will this tension act. Okay, now students, always remember tension always act all away from the point of consideration. See, I'm considering this as my point. Okay, now the tension will always act in this direction. It will always act in the opposite direction of the what? Point of consideration. Did you get it? Now, if I go, let's say, if Abhay is sitting over here and this is my point of consideration, then students, the tension will act what? downwards. Okay, it will be always act in the away direction. It will be in the opposite direction or away direction as regarding the point of consideration. Okay, इसको याद रखने के लिए every student, I know every student knows Undertaker. Yes or no? Undertaker को जानते हो सब लोग? WWE का रेफरेंस जानते हो? Students, let me know. ठीक है, अगर जानते हो, see there is one move of his where it is called choke slam. ठीक है, क्या करते हैं वो? Basically he will hold the net and he'll push out, push. Yes or no? हाँ, very good part. हाँ, तो क्या करते हैं वो? He's holding what? He'll hold the neck basically and he'll push him upwards or downwards. Let's say I'm standing over here. This is my point of consideration and I'm holding that object and I want to know the tension. तो push up करो, तो क्या होगा? Tension ऊपर होगा. अगर मैं ऊपर बैठा हूँ, अगर मैं इधर बैठा हूँ, okay, if I'm sitting over there, then what? I'm seeing downwards, yes or no? Then what? Choke slam करो कि downwards होगा. तो tension कहाँ होगा? Downwards होगा. तो आपको पता चला ना कि कैसे अप्लाई करना है टेंशन. सी वन थिंग इज व्हाट, ऑलवेज रिमेंबर कि टेंशन ऑलवेज एक्ट अवे फ्रॉम द पॉइंट ऑफ कंसिडरेशन. ओके, अदरवाइज रिमेंबर दिस स्टोक्स लॉ. ठीक है, फ्रॉम योर पॉइंट ऑफ कंसिडरेशन either it is upwards or downwards, or let's say this is your point of consideration, you want one upwards, and this, if this is the point of consideration, it is downwards. Is it good? Point of consideration. Is it good, students? Okay, very good. Now, if that is the case, then we are going to talk about more about tension. How will this tension act? Okay. Now, see, as I said, tension will act what? Away from the point of consideration. If I'm taking this as my point of consideration, the tension will act over here, T. And over here, if I'm considering this as my point of consideration, the what tension will act? Sir, about normal force, explain once again. Okay, but the students, can we talk about it soon after the class? So 5 minutes, can you wait and I'll explain about it. Is it good? Okay. So are you able to understand tension now? But students, let me know. So is tension is clear now, or is any doubt over here? Okay, good, awesome. And I said that this tension over here will act what? From the point of consideration T. If that is the case, see, here is another trick for you to understand that, okay, is my, let's say, notation of tension is correct or not? That notation is what? Appears the tension, okay, appears as if what? As tension is trying to reduce the length of the string. Okay, this is a trick for you, basically. This is a trick. So what is happening? See, if my notation is correct, does it appear like this tension is trying to reduce the length of this string? Trying to reduce the length of the string. Reduce the length of the string. Yes. So did you get the tension idea now? See, we know 3 times. Okay, 3, like this idea. How do we? One is point of consideration. If you're considering this point, then do it be away. Yes or no? Second one was what? कौन? Undertaker का choke slam था. एक और था कि if your notation is correct, then the tension will appear as if it is trying to reduce the length of the string. Is it good, students? Is it clear till now? अभी तक सब कुछ क्लियर है कि टेंशन कैसे नोटेशन करना है? Okay, good. If that is the case, if everything is clear, students, then I want to know how will, let's say, tension act over here. Okay, now let's say I'm applying a force over here and I'm trying to pull the object. Okay, I'm trying to pull the object over here with the force F. Let me know how will the tension create, let's say at this point also. The first point as well as the second point. Let me know, students. I want to know, let's say you say that it is in the rightward direction, say rightward, or let's say leftward. So ऐसा easy होगा ना? Students, everyone who's here, let me know how will the tension act. Okay, I want to know, initially I want to know for the first side. Okay. Okay. Left. Okay. Everyone is saying left. Others, let me know. Is there any different answer? Is there any different answer, students? Let me know. Left. Okay. See, I know. See, most of you people will try to what? They will. Okay. There are certain mistakes you do in the beginning. No problem at all. See, students. The first thing is I said that tension will act always in the what? Will act always in the opposite, or let's say from the point of consideration, it will be away from the point of consideration. Let's say if I'm considering this point of consideration, then will the tension act in the left side or the right side? Will it act at the left side or right side? अगर मेरा ये पॉइंट ऑफ कंसिडरेशन है तो पॉइंट ऑफ कंसिडरेशन से वो अवे करेगा, तो एक टेंशन इधर एक्ट करेगा ना, इधर इधर लेफ्ट साइड नहीं करेगा भाई. Always it will be away from the point of consideration. So I'll talk about it now. Okay, I will talk about it. Don't worry. I'll call it T now. Okay. Now, students, if I'm considering this as my point of consideration, तो इधर कहाँ होगा? Where will this tension act now? Let me know. अब किधर act होगा? If I'm considering the point of, like it will act away from the point of consideration. इधर act होगा ना? Yes or no? Very good path. If I'm considering this as my point of consideration, हाँ, अब कहाँ होगा? M2 के पास कहाँ होगा फिर? Let me know, students, everyone. Right. Okay. Very good. Right होगा ना? Yes or no? Now, students, यहाँ थोड़ा carefully observe करो. अगर हमारा notation सही है, तो मैंने बोला था कि third एक trick था कि हमें check करना है कि whether it is trying to reduce the length of the string. Reduce the length of the string. हो रहा है ना? ये वाला हो रहा है, सही है कि नहीं? ऐसा नो? See over here you will have a doubt over here कि ऐसा क्यों act कर रहा है. और एक और है कि मैं इसको जो डिनोट करूंगा वो मैं T से नहीं करूंगा, सेम टेंशन से नहीं करूंगा. I'll tell you why. The reason is over here we have two strings. This is string one. Okay, just a second. Okay, this is string one and this is string two. Yes or no? See, so I wanted to appear on a node that whenever there are two strings, two separate strings, then what? Different tension acts. Okay, different tension acts basically. Okay, different tension acts. For that reason, students, if this is T over here, then I will denote it as what? T1 and T2. Okay, I'll denote it as T1 and T2. Now you got to know that why this tension over here was acting away from this point. Did you get it? Okay, and always remember it will be always from the point of consideration, away from the point of consideration. So don't confuse it. Is it good? Okay, is it good? Everyone. Yes, others, let me know. Parth, Meera. So students from Kodagu, students from North Canada, if you are able to, let's say, reply, it would be very helpful. I can know that students are able to understand. Okay, Ansari, very good. Okay, so you got to know how you denote the tension. Okay, is it good? Now also I said that what when there are two separate strings, what different tension acts. Parth, oh nice. Okay. No problem, Parth. It's fine, no problem at all. Okay, so you are attending the class. That's very good. Okay, so as I said, if you have two different strings, then different what tensions act. Okay, Parth, very nice. Okay, now see, there are certain points regarding tension. Okay, what I wanted to say was where I wanted to appear on the important point was, see, tension will remain same if the string remains same. Over here we observe that if there is a same string, this is the same string and this is one string. Yes or no? This whole is one string. For that reason, the string, the tension remains same. Okay, and since this was another string, the tension was T over here. Okay, students, is it good? And the next point is what? If the string changes, tension changes. Obviously, we saw that there was two tensions, T and T2. Okay. And there is one important point you need to keep in your mind. Okay. Even if it is not said in the coming classes, let's say there are problems, you need to keep in the mind that most of the time the string is considered to be massless and frictionless. Okay. This is very, very important, students. So always remember the string is always considered to be massless as well as what? Frictionless. Is it good? So please note it down. Everyone who is listening to the class, note it down. And write it as what? Important. Very, very, very important. You should never forget this. Because if you forget this, you will not be able to solve any problems. Okay. In order to, what is a string? Let's say a rope. Okay, a string, a rope. अगर मान लो एक रोप है उसको स्ट्रिंग बोल सकते हो ना. Or let's say, okay, let me do one thing in the next class. If I get a string, like a pictorial representation of the string, I'll show you. Is it good? Ha, Parth, I'll send you these screenshots. Okay. So what we are going to do is, okay, everyone who didn't receive the this thing and all PDF, we are going to create a separate drive for what? Class 11 students. Okay. We are going to do that and we are going to share it with you. Okay. So it will contain all the PDFs. Okay. All the PDFs of today's class. Today's, yesterday's, day before yesterday's class. Is it good? Parth, is it fine? So most probably it will be sent in groups. Others, don't worry. I'll give the subsequent updates. Okay, for you. So anyways, the drive is done. We are collecting all the PDFs, all the necessary study materials, and we'll be putting into one certain drive so that every student will be able to access at any time. Okay, na? It will be very helpful, right? A drive will contain every information. Nice, nice. Okay, very good. Cool. Now, if you are talked about tension now students, I want to know, please plot it and let me know. I'm giving you 2 minutes of a time. You need to plot the tension in the string. Okay. And after that, I will ask from point 1, from point 2, and from point 3, where will the tension happen? Okay. So I'm launching let's say, the timer. I'm giving you 2 minutes of your time. So everyone has to plot this. Okay. Everyone has to plot this. And the time has started. Please start doing it. Draw the object. Let me know where will the tension add. And in the meantime, if you have any doubt, let me know. Yes, Parth, let me know. JNV Kodagu students, North Canada, please make sure that you're solving it. Okay, Ballari students, Suhaib, Madhiha. Okay, last 40 seconds. Last 40 seconds. Okay, last 20 seconds, students. So make sure that you're ready with your answer and cross verify when I'm doing it. Okay, let's cross verify. Last 5 seconds. Okay, time's up. Okay, so most of you have done. I hopefully think that you guys have solved it. Okay, See, first, let us consider from this point. Okay? From this point. Let's say from this point, where will the tension act? To the right or to the left? To the right or to the left? Let me know. To the right or to the left? Yes, very good. It will act to the right. Yes, very nice. See, okay. Now let me know. Are there two strings or one string itself? Are there two strings or one string itself? Two, right? Yes, because this is string one. This is string one. And this is what? String two. So there are two separate strings. So let me take this as what? Tension two. Okay, let me denote with T2. If I'm considering from this point, where will the tension act? To the left or to the right? To the left or to the right? To the left. Very good. Okay. From this point, I'm denoting. Very nice, everyone. It will act to the left or to the right. Let's say upwards, away from it, or let's say to the right. Okay, very nice. Left, yes or no? That is what? T1. And if I'm considering from this point, how it will be? It will be from this point, that is T1. Is it clear, students? Did you get to know how to draw tension now? Pura clear hai na? Yes, very good. Very nice. That's very good. Okay. Thumbs up for you all. Clap for yourself. Okay. Nice, students. Now, see, the thing is, this tension basically has to be applied in Pulley problems. Okay. We are going to study about this after Newton's second law. But the thing is, what I wanted to make sure is, you know where you can apply tension in the Pulley problems. देखो, जो हम प्रॉब्लम सॉल्व करेंगे ना वो अलग होगा, लेकिन टेंशन तो पता होनी चाहिए ना. वो देखो, टेंशन पता होनी चाहिए such that there is no tension when solving problems. है कि नहीं? ऐसा नो. टेंशन कहाँ मतलब फिजिक्स का टेंशन पता होनी चाहिए such that जो एग्जाम का टेंशन है वो दूर हो जाए. Is it clear now? Okay. Is it good? Let me know, students. Yes, nice. Okay. In Pulley problem, one of the most important thing is what? It is considered to be massless. It is considered to be massless and it's said to be what? Frictionless, students. So ये दोनों point important है. Pulley problem में भी मैंने वही बोला lastly. ठीक है? Now, considering the Pulley problem now. Okay. Now, students, see, if this is the Pulley problem and it is attached to a surface over here. This is the pulley. Basically, this is the pulley. ये ऐसा दिखता है आपका pulley problem. And there are certain, let's say A, B, and C masses over here. Okay. Now, students, let's consider mass A. Will there be a weight acting over here? Weight is equal to MAG. ठीक है, एक act करेगा, ऐसा no. Similarly, for C, there will be a weight acting. That is what? W is equal to MCG. And there will be a weight acting for what? For B, that is what? MBG. Yeah, ठीक है ना? All the things are fine. Yes. Now, students, how the tension will act? Okay. Now, students, see over here, as you can see that there is this whole string over here. This complete string is one string. ठीक है? ये जो string है, ये एक complete string है, एक ही string है. ठीक है ना? जो red वाला मैंने denote किया है. Okay. So this is one string, that is string one. Huh? Now, एक और है यहाँ. See over here, you can see over here is that, okay, just a second. Over here that there is another what string, that is what? It is what? Holding the pulley over here, and that is what? String two over here. Yes or no? Now, very nice. If that is the case, now let us apply tension over here. ठीक है? अब tension apply करते हैं. इस पॉइंट में टेंशन कहाँ होगा ये बताओ. इस पॉइंट में टेंशन कहाँ होगा? ऊपर होगा या नीचे होगा? Will it be upward, downward? Yes, very good. मैं इसको T पे डिनोट करूं, ठीक है? Okay, very nice. B at point B, where will it be? Let me know, upward या downward? जो ये वाला पॉइंट है. नहीं. अबे, I'm considering this point of consideration. हाँ, Parth, very good. Up, very nice. Then we Ballari students, see, so what? It will be upward, students. See, it will be away from the point of consideration. वो याद रखो. You need to understand that. Other than PD, it is away from the point of consideration. Okay. So it will be T or T1. Let me know, students. ये जो टेंशन है वो सेम ही होगा या अलग होगा? जो टेंशन हम देख रहे हैं अभी सेम होगा ना, क्योंकि मैंने बोला कि वो एक स्ट्रिंग सेम है, तो फॉर वन स्ट्रिंग दी टेंशन विल बी सेम. टेंशन इज सेम फॉर अ स्ट्रिंग. डिफरेंट स्ट्रिंग होगा तो डिफरेंट होगा. ओके, नाउ फॉर दिस पॉइंट, फॉर पॉइंट दिस व्हाट टेंशन विल एक्ट व्हाट? नहीं 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 मंथन, कहा होगा? इट विल बी अवे फ्रॉम द पॉइंट, इट विल बी टेंशन ओवर हियर. हाँ, वेरी नाइस अबे, वेरी मंथन. हाँ, नाउ हियर इज अ ट्रिकी पार्ट. अगर ये पॉइंट ऑफ कंसिडरेशन है तो टेंशन कहाँ एक्ट करेगा? ये वाला जो ब्लू कलर अभी दिख रहा है ना. हाँ ओके, वेरी नाइस मंथन, वेरी गुड, वेरी ओके. Yes, very nice. So tension will act downwards. Is it good now? Very nice. Now also students, when doing pulley problems, you need to consider this point also, these 2 points. Now let me know where will the tension act over here? At this point. Downwards. Very good. Yes or no? Very nice. Over here also it will act downwards. ठीक है ना? Is it good? देखो, फिर भी आपको डाउट हुआ, आप क्रॉस वेरीफाई कर सकते हो. देखो, ये जो वाला नोटेशन है और ये वाला जो नोटेशन है एंड ये वाला नोटेशन है, इट इज अपियरिंग एज इफ वो टेंशन सॉरी स्ट्रिंग को क्या कर रहा है? क्या कर रहा है वो? रिड्यूस द लेंथ ऑफ द स्ट्रिंग. यस और नो? इज इट गुड? ओके स्टूडेंट्स. सिमिलरली इफ आई एम टॉकिंग अबाउट दिस पॉइंट, ये वाला एक टेंशन इधर लगाएगा ना, T2 होगा. हाँ मंथन, कंप्रेस, वेरी गुड. Similarly, if I'm considering this point, there is a tension T2 over here. Is it good, students? अभी तक जो बोला है वो सब क्लियर है? ओके, सो पुली प्रॉब्लम आपको ऐसा अप्लाई करना है, ठीक है ना? इज इट गुड? वेरी नाइस स्टूडेंट्स, वेरी गुड. Others, let me know. Is there any doubt? Okay, Path, very nice. Now, this will be a homework problem for you guys. This will be a homework problem for you guys. I want to know where will tension act in the whole? Where will the tension act? Okay. अच्छा, गरगाड़ी. अच्छा, पता नहीं था गरगाड़ी. ठीक है, मैं प्रोनाउंसिएशन सही है, गरगाड़ी. Okay, so one of your classmate is saying that जो हम ये पुली बोलते हैं ना, जो ये पुली, तो उस पुली को हम गरगाड़ी बोलते हैं. ठीक है, तो पुली और व्हाट? गरगाड़ी. ठीक है, हम यूज करेंगे जब पुली प्रॉब्लम होगा ना, मैं पूछूंगा. ठीक है, गरगाड़ी, इट इज इन गुजराती. नाइस, आई लर्नड अ गुजराती आल्सो. ओके, so see, that's a new part. Okay, we talked about tension also, and we what learned a Gujarati word. A nice learning also. I'm from a place called Puttur, which is in Karnataka. Parth, okay, which is in Karnataka. So this will be a homework problem, students. Make sure that you are able to draw all the tension properly. In the next class, I'll talk about the tensions that is available over here. Okay, so you can cross verify that. Is it good, students? Yes, everyone. Okay. Now, there are certain important points. Okay, there are certain important points about what? Okay, just a second. Sure, Parth. No problem. There's a constant exchange of language also, so I'll also learn the language. It's very nice. I'm okay with that. Okay, very nice. Okay, there are certain important points. This is also very important, students. Okay, coming back to class. Tension force always pulls a body, it can never push a body. Okay, let's say, देखो, can you see my video? Very nice. Okay, just a second. देखो, ये जो वाला था, ये जो स्ट्रिंग था, ये वाला, अगर मैंने इसको मासलेस कहा, सो अगर ये एक वेट है, देन व्हाट? अगर इसको ऐसा पुल किया, मैंने बोला कि एक टेंशन क्रिएट होगा. ऐसा और नो? फिर बट आई कांट पुश इट. ऐसा और नो? अगर मैं बोलूं तो इसको पुश नहीं कर सकता ना मैं, जो ये बॉडी है. कैन यू सी इट, स्टूडेंट्स? ऐसा नो? ये वाला जो है, इसको मैं पुश नहीं कर सकता ना, क्योंकि मैं कंसिडर कर रहा हूं. क्यों? बिकॉज आई एम कंसिडरिंग what the string to be, the string or the rope or the rod to be what? Massless and what? Frictionless. For that reason, students, tension always what? Pulls a body. It can never push a body. Okay, so tension will always act when it is what? Pushing, like pulling a body. Okay, and what? Tension across what? Massless and frictions pulley is always constant. Yes, as we saw that what? Massless and frictionless pulley is always a constant. इसका मतलब क्या है कि आपके पास एक पुली होगा और एक स्ट्रिंग है, ठीक है, एक स्ट्रिंग है आपके पास, एक कॉमन स्ट्रिंग है। तो इस स्ट्रिंग में मैंने बोला था कि पूरा टेंशन सेम है ना, टी होगा। लेकिन अगर एक और स्ट्रिंग आ गया, सॉरी एक मिनट रुको, एक और स्ट्रिंग आ गया तो इसका जो टेंशन है वो T2 होगा ना, ये T1 होगा। पूरा इसके लिए T1 होगा लेकिन इसके लिए T2 होगा। सो बेसिकली दैट इज व्हाट इट इज सेइंग। एंड द नेक्स्ट थिंग इट इज सेइंग इज ropes or strings become slack if tension is zero, है कि नहीं? अभी मान लो कि मेरे पास दो मास है, ओके, and there is certain tension between them. Okay, now if this tension, okay, if the tension what, और let's say जहां अगर टेंशन है, टेंशन की वजह से क्या हो रहा है, वो रोप स्टिफ हो रहा है। देखो एक मिनट रुको, आई नीड टू सी माय वीडियो टू so that I can know that you are able to see it. Okay, okay, nice. देखो ऐसा था, थोड़ा टेंशन था। अगर ऐसा कुछ स्लैक हो गया तो टेंशन नहीं है ना, तो स्लैक होगा ना। अगर टेंशन नहीं है तो स्लैक होगा। ये ऐसा टेंशन था लेकिन अभी टेंशन नहीं है तो स्लैक होगा। तो क्या होगा? सो देयर बी, ऐसा होगा तो ऐसा हो जाएगा बेसिकली, अगर इफ देयर इज नो टेंशन। पता चला अभी द थर्ड पॉइंट। एंड व्हाट we consider what? Our string to be inextensible। इसका मतलब कि जो इसका लेंथ है, there is no change in length। there is no change in length। is it good students? so there is no change in length at all। so inextensible मतलब जो मेरा ये वाला स्ट्रिंग है, अगर मैं इसको खींचू भी there is no change in the length। is it good? Is it good students? Very nice। okay, so what I'm doing is, since the time is up, since we have got only 3 minutes of our time, so I'm going to end the class today, sir, like here, okay, today here, and we are going to talk about the free body diagram in tomorrow's class। okay, tomorrow's class we'll be talking about free body diagram। I'll tell you why, because this is very important to what? Apply all the laws। okay, apply the Newton's laws। so पहले देखो, पहले हमने टेंशन पढ़ा, ठीक है, अभी टेंशन पढ़ लिया तो फ्री बॉडी डायग्राम के बारे में पढ़ेंगे। हाँ, यस यस भाई। सो फ्री बॉडी डायग्राम के बाद हमें जो प्रॉब्लम्स होगा ना लॉस के बारे में, न्यूटन्स लॉस के प्रॉब्लम्स, वो ऐसा हो जाएगा, लाइक आराम से हो जाएगा। ओके स्टूडेंट्स, so before going ahead students, I am just going to what? Summarize today's session। okay, in the meantime I'm also launching the technical check। okay, sorry, NPS poll, I'm launching the NPS poll। okay, and JNV Ballari students, please be here। okay, so I'll be solving your doubt। so in today's class, initially we talked about what? Tension, yes or no, where we came to know that tension, what? Tension acts away from points of consideration, away from point of consideration, yes or no? And we saw what? We saw certain problems also, certain sure, after answering the NPS you can leave the class। okay, no problem। so also problems we also saw that we can apply tension in pulley also, we required to apply tensions in pulley problems, yes। and we saw that in every case, let's say the string is considered to be what? Massless and frictionless। okay, these were the things we what? Solved today or understood today। is it good? okay students, so thank you for attending today's session। okay, we'll be meeting in the next class। take care, bye bye। okay, bye bye। okay students, no problem। okay, so Genvi Ballari students, let me know your doubt, please. Yeah, thank you. And thank you, YouTube Live students.